Alright, hi everyone. This is the solution to number 4 of the midterm review, which is on Newton's method and iterative improvement. So in this problem, rather than trying to find the zeros of functions, we're going to attempt to find the minima of functions. And as we'll see, we'll use both Newton's method and a different iterative improvement method to solve this problem. Alright, so let's get to it. Number 1 asks us, what should the terminating condition be? So what should the done function check for this minimization problem? Well, if you took calculus, the first one that pops out at you is probably that the derivative of a function at its minimum needs to be 0. Okay? Now, for our purposes of writing the second iterative improvement algorithm, which is known as gradient descent, we'll also state a second one, which is that if you think about iterative improvement, where you start at some random value x, which has some random value y, right? Then you iteratively improve its guess, meaning you step more and more towards its minimum. Then eventually, at the minimum, when you're done, the change in the vertical distance should be very small. So that's the second terminating condition we're going to use, that the absolute value is just to sort of get rid of the effect of positives and negatives, right, is approximately 0. So this is saying that a second terminating condition is that given x, which is an old value of x, and x prime, which is the new value of x that I found by updating this x, the difference between their y value should be very small. And if we can detect that, then we know that we have approximately found the minimum of this function.